Hello and welcome to homework 5.04. We are now starting to graph inequalities. We started by graphing lines and now we're graphing inequalities. Now there are a lot of steps to these, so what I'm going to do is I'm going to start this homework by making a checklist, and this is kind of the process we have to go through for each of these problems. Alright, so step one when you're doing these is always to solve for y. Alright, and that was the same for the lines. We couldn't graph lines until we solved for y. Step two is to plot points. Now there are two ways to plot points. You can either make a table or you can do the slope y-intercept method. Alright, so there are two ways in which you can plot your points. Now, those are the same steps that we did when graphing lines. Here are the new steps that we have to consider when we're doing inequalities, because there's two new steps. The third step is, do we need to use a solid or do we need to use a dashed line? So when we're connecting our points, is the line going to be solid or dashed? Step four is to do the shading. So we have to either shade above or below the line. And then step five is to label our line. So if we compare this to graphing equations, this step is the same, this step is the same, this step is the same. It's steps 3 and 4 that are new, so we have to make sure we're kind of remembering those when we do these problems, because that's the new part that we have to worry about. All right, so let's take a look at number 1 here. We have y is less than 1/2 x minus 3. All right, so this one already has the y by itself, so step 1 is already taken care of. So our next step would be to plot the points. So you've got two choices. You're either putting it into your calculator and getting an xy table, or you're saying, all right, my slope is 1/2, because that is the number next to the x, which means I go up 1 and over 2, up 1 because it's positive, right 2 because it's also a positive, so both numbers are positive, so we go up and to the right, and then our y-intercept would be -3, which means when we make our graph, we're going to start down 3 on the y-axis. So let's take a look at what we have here. All right, so we're going to start down 3, so down 1, down 2, down 3, and then we're going to move up 1 over 2. Up 1 over 2, up 1 over 2, and we can also do the opposite of that. We can go down 1, back 2, down 1, back 2, down 1, back 2. Now, this is where we have to slow down, because a lot of kids' instinct is just to say immediately, oh, connect all my plots, but that's not going to work for these. All right? What we learned in class was that when you have a less than or a greater than, move that over a little bit, when we have a less than or greater than, we use a dashed line. When we have a less than or equal to or a greater than or equal to, we use a solid line. So in this case, there's no equal sign there, so we're going to connect our points with a dashed line. Alright, that's kind of the equivalent of the open circle that we saw in the last unit. Alright, so notice my line is dashed. So that's the first new step. The second new step is the shading. Alright, so you're either going to shade above the line or you're going to shade below the line. And it kind of makes sense which way you do it. When it's a less than, you're shading below the line. When it's a greater than, you're shading above the line. So this is y is less than 1/2 x minus 3, so we're going to shade below the line. Now, if you have a hard time remembering which way to shade, we can check this on the calculator. All right, so you can go to your calculator and you can type in y equals 1/2 x minus 3. And then what we do is we scroll over to the left-hand side here. All right, so it's blinking on that line. If we start hitting enter, it'll start rotating through options. There's two options that we're looking for. This is the first one, which is the greater than, and then this is the second one, which is the less than. So if you're wondering like which one is it, the way I like to remember it is the less than one kind of looks like an L, or even just your less than symbol, and then the greater than one, which is this one right here, if we move the paper over, is much more similar to your greater than symbol. All right, so as long as you can keep those two straight, we can use the calculator, type it in the calculator, look at the picture, and confirm that we are shading below the line. So you have two options. You can either just try to remember that less than is going to be below the line, greater than is going to be above the line, or if you're doubting yourself, you can go into the calculator, go to your y equals, and get it from there. Okay. All right. So I have my line, I have my shading. My last step is just to throw a label on this. So y is less than 1/2 x minus 3. Okay. Let's take a look at number 2. All right, number 2 is a little weird because all that's there is x is less than or equal to 3. All right, so there is no y, there's not a y-intercept, we're just seeing this x is less than or equal to 3. So the way that we graph these is because it's x less than or equal to 3, we're going to move on the x-axis, so we start in the center, and we're going to move over to where x is positive 3, which is right there. And then the rule for these is if you start moving left or right, you make your line up and down. So because we started moving left or right, we make our line up and down. This time we have the equal sign underneath it, so it's going to be a solid line up and down. If this had been, for example, there's not on this one, but if this one, for example, had been y less than or equal to 3, it's not that, but if it had been that, then we would have started by moving up 3, so our line would have been left to right. But this time we started moving over 3, so our line is up and down. And then, because that's x less than or equal to 3, we want our shading to be to the left here because these are all the numbers that are less than 3. All right, these are all the numbers that are less than 3. I went a little over there. Don't worry about that. But these are all the numbers that are less than 3, so my shading would be on the left-hand side. And then I would put my label on it up top. X is less than or equal to 3. All right, so they're quicker than the one we did up above, but you do have to kind of remember and keep those two ways straight in your head. All right, let's look at the second part of the question. Determine whether or not each of the following points lies in the solution. All right, so for a point to be in the solution, it has to be in the shaded area or on a solid line. All right, being on a dashed line does not count. Being on a solid line does count. So if we look at this first point here, 5, 3, remember the first number is your x, the second number is your y. So if we go over 1, 2, 3, 4, 5, and up 1, 2, 3, we can see that that point is not in our shaded area. So the answer to this one would be no. If we check out the second point, which is 3, -5, over 1, 2, 3, down 1, 2, 3, 4, 5, right there, we can see that that point is on a solid line, so that is part of our solution. So this one would be a yes. Right? So no for this one because it's not in the shaded area. Yes for this one because it's on a solid line. So we can either say, we could even put reasons below that. Not shaded. And then this one is yes because it's on a solid line. All right, let's take a look at the back. Right? So we have more here that we're just going to be graphing. So this is kind of where that checklist comes in. All right? We're going to start by solving for y. Then we're going to plot points. Step 3 is to figure out whether the line needs to be dashed or solid. Step 4 is to think about your shading. Does it need to be above or below the line? And then step 5 is just to put the label on it. All right, so having this kind of list here is going to make sure that we don't forget anything. All right, so if we look at this first one here, we need to get the y by itself, which means we need to get rid of this 4. That's the one thing that's kind of in our way right now. So this is 4 times y, so the opposite of multiplying by 4 is dividing by 4. All right, so we get y is greater than, if we do 3 divided by 4, it's going to be 0.75, but we can just math frac that back to 3/4 x minus 2. All right. So we did slope-intercept on the first one, so why don't we put this one in the calculator so that we can see kind of both methods. So I'm going to parentheses 3 divided by 4x minus 2. I'm going to go to second graph, and then I've got this table here. I'm way up at 21 right now, so let me go to second window and jump back down to 0 so that I'm not way up there. Okay, so I just want to pick at least 4 points here. Get like a mix of the negatives and the positives. So we'll start with -4, -5. So I've got -4, -5. Next I've got 0, -2. I'll scroll down. I'm skipping anything that has a decimal. And then I've got 4, 1, and 8, 4. So 4, 1, and 8, 4. All right, so I'm now at the plotting the points stage. So I've got my x, which is left to right. I've got my y, which is up and down. And I just need to plot these points. So let's see here. -4, -5 is going to be back 1, 2, 3, 4, and then down 1, 2, 3, 4, 5. 0, -2 is going to be, I don't move left or right at all because that's a 0, but then I move down 2. 4, 1 is going to be over 1, 2, 3, 4, and then up 1. And then 8, 4 is over 1, 2, 3, 4, 5, 6, 7, 8, and then up 1, 2, 3, 4. All right? So this is where we have to fight the urge to just immediately connect the points, and we have to look at our problem. All right? So this is a greater than symbol. It doesn't have an equal sign under it, which means we need to use a dashed line. So I'm going to connect these with a dashed line. Okay, so there's our dashed line. Now we have to think about the shading. So this is y is greater than 3/4 x. So greater than means that we're going to shade above. But again, if you're having doubts or if you don't remember, if you go to y equals, we can scroll over to the left. And then we keep hitting enter, and then we've got two choices. There's that one, which is our greater than, that one, which is our less than. And I think the less than one looks a lot like an L, so as long as you remember that that's less than, you know that the other one is your greater than. So let me just scroll back to that. There's our greater than. We hit graph, and you're going to see that the shading is up above the line, just like we said it was going to be. So the shading will be up above our line, and then we just finish it off by throwing a label on there, which is 4y is greater than 3x minus 8. All right. Moving on to the last one, we're going to follow that same checklist. We're going to start by solving for y, then we're going to plot points, then we worry about dashed versus solid, then we do shading, then we do a label. All right, so if we're solving for y, we need to get rid of two things. We need to get rid of this plus 3, and we need to get rid of the 4. Those are the two things that are preventing the y from being by itself. So we'll start by minusing 3. These will cancel out. We get 4y is greater than negative 2x minus 8. Right? Negative 5 minus 3 is going to be minus 8. Divide by 4, divide by 4, divide by 4. Y is going to be greater than. Now, if we do this on the calculator, it's going to say negative 0.5, which if we math frac is going to go to negative 1/2 x minus 2. Now again, you have two choices. You either put this in your calculator and bring up a table, or you say to yourself, all right, the slope is negative 1/2, which means I'm going to be going down 1 because it's a negative 1, and to the right 2 because it's a positive 2, and my y-intercept is negative 2, so that's where I'm going to start my graph. And the reason I know this is my y-intercept is because it doesn't have an x next to it. The reason I know this is my slope is because it does have the x next to it. So if we go over to our graph, we're going to start down at negative 2 on the y-axis because that's our y-intercept, and then we're going to go down 1 over 2. Down 1 over 2, down 1 over 2, down 1 over 2. And you can also always do the opposite. So I can go up 1, back 2, up 1, back 2, up 1, back 2, up 1, back 2. All right? I'm not going to connect them. I'm going to think. Dashed or solid. All right? We have another one here where there's no equal sign. So that means we're going to be, again, using a dashed line. So dashed, 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 dash, 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 dash. All right. I need to do my shading. If I look at my problem, this is y is greater than. As we've talked earlier, greater than is above the line. But again, I'm going to keep going back to this. We can put it into our calculator and check. All right. We still have the greater than set up from the last problem, so we just change it to negative 1/2 x minus 2. We hit the graph button, and we're going to see that yes, the shading is up above the line. Right, so let's do our shading here. All right, so there's our shading, and then we just finish it off by putting on our labels. So 4y plus 3 is greater than negative 2x minus 5. Okay, so now we have gone through all 5 steps. We solved for y, we plotted points, we did a dashed line, we shaded, and we put on our label. So all we have to do is determine whether or not each of the following points lies in the solution. So we're going to graph these points and see exactly where they fall. Just remember, when you're doing a point, the x comes first, the y comes second. The x comes first, the y comes second. So if we look at this first point, 1, 0, that's over 1, and then we don't go up or down at all. So that's right in our shaded area. So this one would be a yes because it's in the shaded area. If we look at the second point, negative 2, 1. Negative 2 is back 2, up 1. This one is also in the shaded area, so that's another yes. And then last but not least, if we look at this third point here, negative 4, negative 3, that's going to be back 1, 2, 3, 4, down 1, 2, 3. So that's going to be a no because it is not shaded. All right? I'm going to add an extra point here just because I think it's worth kind of explaining this. The points that can sometimes be tricky is if I had given you a point that was, say, negative 2, negative 1. All All right, so if I had done -2, -1, that's back 2, down 1. That's right here on the dashed line. Now this, kids are sometimes not sure. They're like, well, is that shaded? Does it count as shaded? Does it not count as shaded? It's on a line. This would be a no, because being on a dashed line does not count. It's the same as the open circle from our inequality unit. The open circle does not include the answer. It's the same thing here. A dashed line does not include our answer. All right? So that wraps up this homework. I hope it was useful. Have a good day.